Good morning, everyone. Welcome to Machine Learning Best Practices on Digital Hub Part 2 webinar, which we will be continuing our analysis for the Part 1 that we had back in April. Before we get started with the presentation, please notice our legal disclaimer. Material presented here, including but not limited to text, images, and codes, are subject to Digital Hub terms and conditions and are for demonstration purposes only, and may include future product features and plans. Sharing, copying, reproducing, and modifying them in any form requires Integra's permission. Next slide. I'm Hoda Rezai. I'm your host today. Here with me, I have Babak Shafi, Integra's founder and CEO, and Sylvia Lee, our data scientist. A little bit of highlights about this webinar, what to expect to see in the next half an hour. We're going to have an introduction of Integra and Digital Hub. Then Sylvia will be walking you through the machine learning best practices and a hands-on demo on Digital Hub. Please stay tuned for our upcoming webinars. We have one planned for June 8th, which we will be continuing this machine learning best practices on the market pricing electricity data. So you will be able to use this machine learning and predict and forecast your market price and actually make buy and sell decision, which will help plant operator save millions of dollars. So June 8th, you can sign up on our website, Eventbrite, and our LinkedIn page. And then I encourage everyone to join Digital Hub. You will be able to follow along Sylvia during this webinar. You will have access to notebook and data, so you can do analysis yourself. You need to register and sign in on cloud.digitalhub.io. You need to subscribe to a plan. We are offering academia plan for free to students. And also we have a promotion today for webinar attendees that you can use and have access to that academia, which gives you 40 hours of usage on the platform and 5 gigs of storage for free. And please note that this code expires today, so use it as soon as possible. And then to be able to access the notebook and data and follow along during the webinar, you need to create a project, either a data exploration or a machine learning project, and then you can access the notebook from notebook template sections. And with that, I'm going to hand it over to Babak for the introduction of Integra and Digital Hub. To you, Babak.
Thank you, Hoda, and good day, everyone. I can see many people joining us from around the world. It's very exciting. A little bit of a background, as usual, on Integra. Integra is a solution provider focused on oil and gas, and our mission is to bring in data science and machine learning as a capability to our oil and gas industry. And we are specifically focused on use cases where we could actually apply machine learning and data science or AI to solve a specific problem. And the last couple of demos, we've shown how power generation can be optimized and it can be predicted, and it can be optimized in a way that it corresponds to the market demand. So typically, these are the use cases that we develop. On our website, we have more use cases on pipeline integrity, on pump predictive maintenance, so on and so forth. And our goal really is to bring our oil and gas expertise. We feel this is an important part that needs to be part of every data science solution, and a platform that anybody can do data science and collaborate as a team, and a community to share the learning and development. We alone cannot advance this field if it is just a transaction based where companies buy our services. But if we create that community and collaborate and share and learn and work together, we can advance this field in data science and make oil and gas industry, which is aging and again, an exciting field to work for. Next slide, please. Digital Hub was our own platform we used before COVID to deliver some of our projects. And then during COVID and the downturn, we decided to make this a public platform so everybody can access. So what you would have access on Digital Hub is technically the same as multi-million-dollar platforms that other organizations invest in. And the ultimate goal of Digital Hub is to be self-serve. So you can do it yourself. So if you have a small team, or you're part of a small consulting or service provider, or you're a freelancer, you don't need to have the IT background to set things up. All the packages are pre-configured. Everything is installed and maintained. It's very cost effective. You can start, pause, and play. You know, we give free 40 hours to try things out, and it's actually recording monthly. So every month you'll have 40 hours. But at the same time, you know, you can add more hours to your plan and continue to use it, or pause it. So having a project doesn't necessarily mean that it will be cost. You have multiple projects, and it's end to end. So you can do data exploration, you can do data science, you can do machine learning, you can do automated machine learning, and you can do data visualization and business intelligence. And this will eliminate a lot of the low value data science activities, such as installing packages, configuring packages, maintaining them, and updating them. It will take that away from your hand, so you can focus on solving the problem and focus on applying the data science. Next slide, please. So who is Digital Hub for? We had 3 groups in mind, and obviously there's more people who will somehow resonate with these groups. Obviously, it was engineers. You know, our background is in engineering and in oil and gas. We wanted these engineers who actually have the knowledge of the data and expertise, but they don't have the right tools today in the organization or as individuals to be able to practice data science. You know, with very basic machine learning and data exploration techniques, as hopefully you know, you can extract tremendous value from your data, especially if you're just you know, geologist, or you're a mechanical engineer or electrical engineer. You can gather lots of insights on your rotating equipment, on, you know, the reservoir that you're studying, by a few basic techniques. So it is important to have that tool, and we wanted to make it very easy for everyone to have. The other group is data scientists, who actually have the statistical background, the scientific background, and researching, and so on and so forth. And we wanted to have to give them the environment that is ready to go, so they don't have to maintain, they don't have to add and move components and constantly battle with version controls and security and other elements. And finally, the business analysts who, you know, make sense of this data and is able to tell this story. We have created this intelligence capabilities in the platform, so they can all work collaboratively together. Next slide, please. With this introduction and intro, I'm going to hand it over to Sylvia, who is going to walk us through the best practices on Digital Hub. Thank you.
Thank you, Babak. So before we actually get started with the rest of the demo, we do have a poll with 3 quick questions that if we can please ask you to take a few seconds to answer. So for us to just know a little bit more who's out there, what background you're from, what's your expertise with data science, and maybe like what you want to see from us in the future. So if you can just take a few seconds for us to answer that, that'd be great. Thank you. But for the rest of this demo today, what we're actually going to go through is a continuation from part 1. So we'll review some of a little bit more about how to get started with machine learning. So defining the process and defining the objectives. And then we will focus on a demo that's specifically on hyperparameter tuning. Last part 1 with the feature engineering. So this time we're going to do hyperparameter tuning and the model optimizations. So just a quick review on the next few slides. We have talked through these slides in part 1, so I'll make it relatively brief this time. If you want to know more about what was the content of these slides in details, please go back to the part 1. We do have the videos up in YouTube that you can review. But just 2 quick oversights in general. When you get started with data science, this is something we've learned in the past, is lose sight of what's important. The data is the most important part. You're trying to get insight out of the data. So when you do data science, you want to make a model that works best for your data and not the other way around. So not get distracted with all these exciting machine learning models, but you want to identify what's going to be best for your data. The next is sometimes having a simple simple problem statement doesn't mean there's no value. Sometimes a simple model can give you as much value as a very complex deep learning model. So with getting started on data science projects, it's usually a lot of time a small part of a big business problem, and you want to find the most critical part to start with. Now, to find the most critical parts, we have identified 4 big fields in which you can think through to guide you to establish your problem statement. So to learn more about your data, to know what your problem is, what the nature of your problem is, and you also want to know the ethical concerns. So then what are the protective measures that you might have to put in place throughout your whole data science project? And then lastly, to envision where that final product is going to be. So how is it going to be used? What is this going to be used for? So these are 4 big areas to consider when you establish your problem statement. In terms of the machine learning and data science, we have summarized it into 3 big iterative processes that we've seen from our experience. So in the very first stage, you go through your EDAs, your data exploration. As you know more about your data, you can fine tune and actually adjust your problem statement and then go back to your data and see if the adjustment works. So there's a lot of iteration in that exploration stage, or you are trying to lay the foundation and know where you're going to be with your problem statement. And then you have your development stage where we go through, you work on your data with feature engineering, and then you work on your model with model optimization. You go through this iterative process to make sure you have the best transformations and the best model to go on forward with. Once you have your model, then it goes to the model growth stage where you actually put your model into use. And while it's being used, you gather the data that it's being trained, that it's predicting on. You gather whether it was right or wrong. You add to your training pool, and then you make your model more sophisticated as you retrain it and redeploy it. And then that cycle iterates through for your model to grow and become more sophisticated for your use case. So for the rest of the webinar, and from the last webinar, we have been focusing on this development stage. So we did feature engineering in part 1. So today we're going to focus on model optimizations and the hyperparameter tuning process. So just a little bit, overview of this machine learning series. Just as I said, part 1, we did the feature engineering and some of the best practices on Digital Hub with Git and Conda. So we're going to do hyperparameter tuning process for today's part. And then the next part, on June 8th, we're going to be actually going through a little bit more on the model validations, integrating the market analysis, and showing the results from the market analysis on a dashboard in Superset. So with that, I'm going to now head over to our Digital Hub platform here to show you around for a quick demo on Digital Hub, and then we're going to go through the notebook. So if you haven't already have a account with us, you can come into our Digital Hub here at cloud.digitalhub.io. That's how you can access the platform here. If you don't already have accounts, feel free to come in and sign in for that free account. But in this case, I'm just going to log in and show you around. So if you have been on Digital Hub with us before, what you're actually going to come in and see is that we have a brand new homepage where we have actually included a lot of different resources like video tutorials, how-to guides, and also some blog posts that might be interesting to you for reading. A quick pie chart here to show your progress. So this is a brand new homepage, very exciting. Feel free to go in and explore around. If you haven't had an account with us and you just signed in, we do ask you that you get a subscription with us before you can create a project. So you can do that by going under subscription, pricing, and then select the academia plan, which is the free plan with 40 hours and 5 gig of storage. You would be asked to enter in your payment information and also the promo code into that student aid section, and then you will be able to get access to all of the content for free. So if you're wondering where did that old homepage go, right now it's under develop and build projects. So in here, you will be able to see that old homepage where it has a list of all of your projects and the project that has been shared with you. If you're new to our platform, to follow along, you can just quickly create a project with us. 4 quick steps under develop, create project. So in this case, let's say I'm creating a machine learning project. I select my components, which I want all of them. including H2O. So you really want this one because that's where we're going to be having access to Jupyter and the notebooks. Let's say I have a team subscription, so I can add a member in here. So let's say I add Hoda as one of my members. I'm going to give her an owner role. Then next, I'm going to do my project details in here. So then let's just say I'm doing this is machine learning, part 2. So hyperparameter. Okay, learning and quit. So with 4 quick steps, you can get in, and it would take a couple of minutes for your project to get created. So it will launch up all of these components for you with a centralized database in the backend that connects all your components. But for the purpose of this demonstration, I'm just going to go into, still get used to the old homepage. I'm going to go into my Power Plants prediction here and launch up my Jupyter, which I actually already have. So inside your Jupyter lab here, just let me increase a little bit so it's easy to see. So what you will want to do in order to follow along, so once you have access into your Jupyter, what you will see in the launcher is the template section in here. Click on the template section, select the Digital Hub template, and then select the DHML hyperparameter tuning notebook. So once you select that, you will be able to follow along inside the notebook there. For the first part of this series, this is located in the DHML feature engineering notebook. So in that one, you can go ahead and then see what was the notebook from the first series that we went through. So while the notebook comes up. So I'm just going to, for time purpose, I'm just going to restart my kernel, run all the cells. So again, for this entire series for machine learning, we'll be going through the electricity generations. So then having a data set from a combined cycle power plant, and then we're going to try to predict the hourly electrical output. And then in the last part, we'll be combining it with market data to show the values. So just bits of a concept in here. So we're going to be going through hyperparameter tuning. So what this is the process of like trying to make your model work best with the data that you give us. So we can't really control how the model trains, because that's really the beauty of machine learning, is that it knows how to train. Once you give it the data, it will fit the parameters for us to be able to best transform the input data into the output predictions. But what you could do to optimize your model is tune the hyperparameters. So these are the rules and framework in how your model fits your data. And then by adjusting these hyperparameters, we kind of optimize the model fitting, adjust for bias variance, and then also like make sure that your model fits best with the data that you give it. We're going to also introducing a new type of validation technique called k-fold cross validations. So if you remember from part 1, where we actually just split up our data into 3 sets, training, tests, and validations to evaluate the performance of a model with just the test set. Cross-fold validation is a slightly more advanced technique in validating, in which we actually just split up our data in 2 sets. We leave the validation set at the very end to test our final model, but the training set, it gets split up into, say, I'm doing 5-fold in this diagram here. So it gets split into 5 different sections, and then each section takes its turn in becoming the test set, and then the other 4 takes its turn in becoming the training set. And then the final performance of the model would then be the average of the performance through these 5 iterations. For more details on the cross validations here, we have included some references, and also in the hyperparameter tuning, there are some references at the end of the notebook that you can go in and read a little bit more. In general, it's a repetition of that. So we are using some of the libraries in here. So again, all of the common libraries, scikit-learn, plotly, matplotlib, numpy, pandas programming, and skyline. For data exploration here, so again, we have power plants data where we actually have the data for temperature, the pressures, and the humidity. And then we have our prediction value, which is our hourly energy output. So this is the data set that we have. We put it through the pandas profiling library here. If you want to know more about this library, refer to our EDA webinar, where we go through every section of this widget that it returns. But in general, what it actually just gives us in this EDA is that we can go through and look at how our variables look in all of them. And with this data set being the demonstration data set, it's a very beautiful data set with no missing data, and everything is very perfect. So you can go through the widget there and explore that a little bit more. And so finally, we get started. Let's say we're good with our data exploration. We get started with our machine learning here. Again, the first thing we do is to split up our data set. In this case, I split it into two different sections here. So I left about 20% as my validation set that I'm not going to touch until the very end once I've established my model as the final check. And then my training set here, 80% to be used as the training test portion for cross validations.
Sylvia, we're just getting a little feedback on the audio. I think maybe if you I don't know what you can do right now, but a couple of participants are saying that the voice is cutting in and out. We will have the video of this recording, but at the same time, if maybe perhaps if you can get closer to the microphone, that'd be great. Thank you.
How the microphone works. Do I sound okay right now? I'll try to turn down the audio a bit.
It is fine on my end. I just wanted to reflect the feedback.
Oh, okay.
But it is okay on my end.
Maybe I'll turn off the video and maybe that would help with the intro. So you don't get to see me now, but you get to see the look. So again, so we'll be splitting up our data sets here into the training and validation. And then what we have done next is the feature engineering. So again, with a little bit more details on the feature engineering, please refer to our part 1. But overall, basically what we did, apply some standardization and normalization on our continuous variable here, took the date time to extract out the month, and then put it into a few categories in terms of the date, being in the beginning of the month, middle of the month, or at the end of the month with one hot encoding. So now we're going to actually get into the hyperparameter tuning process. So everything before that, you can we get to more details in previous webinars. With the hyperparameter tuning process, so this is a continuation from last time. What we have seen last time is that the support vector regression model, so the SVR model, it gave us the best testing results after we have transformed our data. So with this session, we're going to focus on this model. I took a look through the scikit-learn documentations. It's a very good documentation if you want to learn more about what hyperparameters is for what model and what they are. So then I have identified 3 different hyperparameters that I want to try tuning. So there's the kernel, which is the function that the support vector uses to make the classification or the regression. So there's linear, polynomial, RBF, and sigmoid models out there. The C, which is the regularization parameter. So it kind of determines how generalized you want the model to be. So the lower the value, the more generalized it would be. And then the gamma, which is the kernel coefficient for the RBF and the polynomial kernels. So these are the 3 hyperparameters that I'm going to use and put it into the hyperparameter tuning process here. We're going to go through the 2 common type of hyperparameter tuning process, which is the grid search and the randomized search. So I'm just going to a little bit more in there. We'll talk about each of them in a little bit more details. But first, before we actually get started with the tuning process, I just have the baseline model here. So in this case, I'm just using all of the default hyperparameters from the scikit-learn model, and then getting a cross-validation score out of it. In this case, I have a test score of 0.90. So this is now the baseline score that I'm going to try to improve upon throughout the rest of the hyperparameter tuning process. So we'll first get started with the grid search in here. The grid search, what it actually does is that for each of the hyperparameters that we've seen, we as the user, we're going to give it a discrete list of values. So then what the grid search is that it will do an exhaustive search through all of the combinations of all the hyperparameter values, and then return to you the best result. So for every single combination of hyperparameters, it would do a cross-validation on it to get and then score the model on that performance on there. So with the grid search, it's pretty much guaranteed that within the list of values they give it, it will find you the best performing model. But it also, because it goes through an exhaustive list, it's an exponential increase in computation power and time when you want to add more values to explore. So then this is what kind of the pros and cons within the grid search in here. So you can see in here with every single hyperparameters that it defined in here, it will go through all 9 possible combinations and find it. Whereas with the randomized search, we'll talk a bit more as well. Instead of giving it a discrete set of values, if it is a continuous variable, you can actually give it a distribution, where in the randomized search, you go through a certain set of iterations that you can define yourself. And then it will, for every single iterations, it will take a sample in either the discrete list you give it or in the distributions, get a combination out of there, fit the model on there, and then throughout all the iterations, then return to you the best model out of all the iterations there. So in this case, we've just done in here. So this is the code for performing the grid search. I'm just using the grid search from the scikit-learn library in here. So on my 3 different hyperparameters, I've kept the list relatively short for demonstration purpose. So just 2 values for each hyperparameter here for a total of 8 different models that it could build. Because it's doing 5-fold cross-validation, that comes out to a total of 40 model that's actually building and evaluating on. So with that best score there, I can actually get a 0.92 as the best score in here, and it also returns to me the best hyperparameter. Prior to this demonstration, I did run the grid search with slightly more values inside for every single hyperparameter here. Comes out to a total of 225 models, and then took a total run of about 5 minutes. So you can see the number of models that exponentially increase in so this time. But it does give me a slightly different best score and slightly different hyperparameter combinations to go with. So that's cross-validation. So I think that's relatively easier to simple. It just goes through every single combination, fit the model to it, get the score out of it, and then compare the scores. With the randomized search, so I've mentioned before, you can give it a distribution for your continuous variable, and then for certain sets of iterations that you let it do, it would then find the best scores and the best combination. But because it's randomized, every single time, you're gonna get slightly different results. So the pros in here is that with randomized search, you can actually control your operation time and the number of models that you want to evaluate. It's very sufficient if you don't really know much about your hyperparameter space and how does your model perform. So then for you to kind of explore that space. But the cons is that because it's randomized, there is a chance that you could just miss out the best place possible. And then how you define the distribution of your hyperparameter is also a bit of art. So to go through with it. So then it can lead to long times as the model try to run and converge if your distribution is not quite right. But here we go through a randomized search. So what I did is that I put a log normal distribution for my C and my gamma, whereas my kernel just remains as a discrete list for categorical variables. So I did it through iterations of 8 times, so keeping it consistent with the grid search just now with a total of 40 fits. So with that, the best score that it gets returned is actually very similar with 0.928, and then here is the random list that it returned with the hyperparameters here. Prior to this, I did run it with 100 iterations. It took me 11 minutes to finish the whole running. And then, but the scores that it does give back is a little bit higher, and the hyperparameters that it gives back is also different. So for the rest of the notebook, as we try to explore this hyperparameter space, I'll actually use the data that I've extracted from this 100 iterations run. So all the scores and the hyperparameter from it, so we can just kind of showcase this concept of the hyperparameter space a little bit more. So in this case, this is the code that I used to run that 100 iterations. If you like to run it, feel free to just copy and paste that into a code cell and run it. Do keep in mind it does take a while to run. But I did extract all of my data into a CSV that you'll be able to just read it and continue with the rest of the notebook. So in this case, it does give me back the mean fit time, the mean test scores of every single parameter values that we tried throughout that 100 iterations. I put it into a quick plot on here to see. So in this plot, what you can see, every single plot is a kernel, and then the color is the score of that model. So you can kind of see that for almost all of these kernels in here, the hyperparameter C is going to be affecting your performance more. So what I would actually do in this case then is to kind of identify what are the spaces in here. So I have a better idea of what are the range of hyperparameters that I want to go with. And from there, I could either run another randomized search with more iterations in that limited space to identify the area that is the best performing model a bit more, or actually just go through with a quick search with a fine-grained detail to find exactly where that space is. So this, with two hyperparameters, this is relatively easy to visualize. But that's kind of, in general, the stages for the hyperparameter tuning. So you have a vast space to explore. You go through with a randomized search to kind of slowly limit that down, that space towards specifically that model that's best with your data. Do keep in mind with different data, different model, your hyperparameter, how it changes and how that affects your performance of the model is going to be different. So with that, we're actually going to wrap up the introduction in the hyperparameter tuning process in here. That was a lot of information. We do have the rest of the notebook going through model validations, but we'll also be going through that in our next section, where we actually combine it with the validations from previous sessions, as well through comparisons, included with market data, and also visualize it on supersets. So keep staying tuned for that. But feel free to just go through with the rest of the notebook on your own as well, to just kind of look through how we applied the feature transforming and also use the model that we have tuned, and then on the validation set that we didn't touch, and then go through the rest of the validations here. So with that, I am slightly over time again. But with that, I'll hand it back to you, Babak, to wrap up this session.
Thank you, Sylvia. Thanks, everyone. We went over, as usual, a few minutes. But hopefully you'll find this useful. Please reach out to us on LinkedIn, also on the community.digitalhub.io, or on the platform, or via email. We would love to hear your feedback. We'd love to know if this is helping you with the transition that you're making from engineering to data science. We know it's very difficult, and there's lots that learning away, and start with actual use cases and actual outcomes for you, so you can start to put the practice and the science together and start to immediately use it in some of the use cases that we'll have. We just did a poll earlier today, but we will show the results in the next session that we are together. Overall, however, the results were most of the people who are participating in these events are engineers and data scientists, and the topics that we have posted, everybody was interested in different topics. So thank you for that encouragement. We really appreciate your feedback, as I said, and hopefully you'll find this session informative. And we'll see you on Digital Hub with additional notebooks and additional use cases to solve.